Hello children, welcome back to the channel. Today we will be discussing the topic of a particle moving in a vertical circle. What we mean is that a particle is tied to the end of a massless inextensible string. The mass of the particle is m. Let's say it is hanging from a point O. Now it is given certain velocity at the lowest point of its spinning, and let's call this velocity u. Because of this velocity given, the particle will move in the counterclockwise direction, right? And because it is tied to the string, so it will start traversing a circular path. Now what we want to do is that we want to find that under what condition the particle is going to be able to complete the vertical circle, and under what condition it is not going to be able to complete the circle. Next thing is that we want also to find that what is going to be the tension in the string. Okay, let's start with the first basic question is that when it is moving, or when it's imparted certain velocity, it will start moving, and as it traverses this circular path, it is not going to be the case of a uniform circular motion, because there is going to be gravity that is going to slow the particle down. The velocity is going to change not only in direction but also in magnitude. So to solve this problem, to find the minimum velocity required at the bottom so that it can complete the circle, and the other aspects, if the minimum velocity is not imparted, if the velocity is less than the minimum velocity required to complete the vertical circle, what will happen? To discuss all these things, let's first start with finding how the velocity is going to change and how to find the tension in the string. To do this, let's consider a random point, say P, in the path, say here, when the particle reaches this particular point. So let's call this point L, the lowest point. Let's call this point P some random point, arbitrary point, where we want to find the velocity, which will definitely be tangential to the path, like this. What will the magnitude of the velocity? Let's call this V. And also, when it is here, let's say the tension in the string be T, capital T. Now, what are the different forces that are acting on this? Clearly, there will be the weight of the particle that is acting vertically downwards, right? Let's call this mg, where m is the mass of the particle. Then we can always resolve this mg into two rectangular components. One along the radius, the radial component like this. The other one tangential component perpendicular to the radius like this. So this will have a value of how much? To find this, let's say this angle is theta, angle subtended by the string when it is at P at the origin with the original position, right? Theta. So this angle will be theta. So this will be mg cos theta, and this will be, small m, sin theta, right? So now we also need to notice is that when the object reaches here, the height of the object changes. So when it reaches here, from the initial position, it has acquired a height of h, say, and let's say radius of the circular path be r. Okay, so this distance O to this point will be r minus h. Clear till now? Okay. So now what we have seen is that initially the object was here, it was given certain velocity, and let's consider it as the ground level, the lowest point. So if we consider the principle of conservation of energy, what we will have is that energy at point L, total energy at point L, total mechanical energy, must be equal to total mechanical energy at point P, which means that conservation of energy will give us that what will be the total energy here? Half m u square. Kinetic energy, and since it's the ground level, the potential energy will be 0. And what is the potential total energy at point P? Of course, its velocity becomes v, so it will be half m v square plus the potential energy. What will be the potential energy? Because the height has increased against field of gravity or the force of gravity, the object has moved up by a height of h, so it will be m g h. So these two must be equal according to principle of conservation of energy. This will give us, m's can be cancelled from here, so we have v square plus 2gh equal to u square. How did we find this? By multiplying both sides by 2. Okay, that is to say, v, the magnitude of this velocity at point P, must be equal to u square minus 2gh, whole thing under root. Okay, this is one of the important equations for us, so we will keep this here. V equals to u square minus 2gh, whole thing under root. Let's call this equation number 1. Okay, now let's consider the tension. To consider the tension, what we see is that if we consider the forces acting along the radius, we can apply Newton's second law of motion to that. What are the forces that are acting along the radius? Is tension towards the center, then mg cos theta away from the center, but since it is traversing a circular path, this net force is providing us the centripetal force required to keep the object moving. So this must be equal to m v squared by r, because centripetal force is given by mv squared by r. If you want to see the explanation, then you may please refer to my video on centripetal and centrifugal forces. The link is given in the description below and all. Okay, so if it is so, then what we can do is that we can say that tension at point P in the string will be mg cos theta plus mv square by r, right? mg cos theta plus m by r into v square. However, from equation number 1, we can say that v square is u square minus 2gh. So we will substitute the value u square minus 2gh. Okay. Now this is equal to mg. Now if you look at the triangle formed here, O, let's call this any point, say A. OAP, this is theta. So cos theta will be given by base by hypotenuse, that is r minus h divided by hypotenuse is r, plus m by r u square minus 2gh. So take m by r outside, m by r, then we get gr minus gh plus u square minus 2gh. Or we can say T equals m by r multiplied by u square plus gr minus 3gh. That is the generalized expression for the tension in the string at a given point P. So since it's an important equation for us, we will keep this aside again. So T equals m by r multiplied by u square plus gr minus 3gh. This is equation number 2 for us. Alright, now let's find the tensions at two specific points. One is the lowest point of the trajectory, L. At L, what will be the tension? Let's call this TL. TL will be given by this equation. Here you can see that M, R, U, G and R, all these things are constants. 3G is also constant. Only thing that is variable is H. H, as you move along, the H will keep on increasing till it reaches the topmost point. Let's call this H, the highest point of the trajectory, which will be here. Okay, so for TL, what we have, L, H becomes equal to 0 because it starts at the lowermost point. So we have M by R U square plus GR minus 3G into 0, that is definitely 0. So TL will be this only. Now at the highest point, here height will be the diameter of the circle, so that will be equal to 2R. Therefore, we have T at the highest point will be equal to M by R U square plus GR minus 3G into 2R, substituting H with the value 2R. And if you simplify, we will get M by R U square minus 5GR. This will be the tension at the highest point. Now, if you consider equation number 1 and 2, Roman 1 and Roman 2, what you see is that TL is M by R U square plus some term, right, GR. TH is MR U square minus some term, and this term is 5 times GR, the same GR here. So what we can say is that clearly that TH must be less than TL. And by how much it is less, we can simply find by deducting TH from TL. TL minus TH will be given by, if you simplify this, you can clearly get that plus minus minus, that will be 6GR. Into M by R. This M by R is here. That is to say, TL minus TH equals, RR will cancel, 6GM. So tension at lowest point minus tension at highest point equals to 6GM. This is our equation number 3. Now we are in a position to find out what should be the minimum velocity at L so that the object is able to complete the vertical circle. So what should be the minimum velocity of that should be imparted at the lowermost point so that it can reach here and then move on. Now, to find that, what we need to understand is that when the object is going to leave the circle, see, the string is tied to the object and the object is moving. This string will be taut as long as there is tension in the string. If there is no tension, the string will be slack. And if it slackens, then the object will leave the circle. So, for the object to be able to move along the entire path and reach this point, the tension cannot become 0 before it reaches the highest point. It can be 0 only when, or the lowest value of it can have 0. It can have 0 value only when it reaches here, and then because of the inertia it will keep moving, and then the tension will again generate due to symmetry of the thing. So what happens is that for the object to be able to reach here and then complete the vertical circle, the tension at the highest point must be either greater than or at least equal to 0. Okay, which means that we must have M by R U square minus 5GR must be greater than equal to 0. M by R cannot be 0, which means U square minus 5GR must be greater than equal to 0. M by R is anyway greater than 0, greater than equal to 0. This will give us U square must be greater than equal to 5GR. Thus, U minimum that is the minimum velocity to be imparted at this point for the object to be able to complete the vertical circle will be equal to, because the minimum value of from this u square can have the minimum value is equal to 5 gr. So u will be, minimum value of u will be root over 5 gr. If it is so, then from equation number 1 what we get is that v square equal to u minimum minus 2 gh. However, now we are determining at the point h, for which small h is equal to twice r. So we substitute the value, v square will be equal to 5 gr from here minus 2g into twice r, that is to say gr. This gives us v will be this. This particular value of v is known as the critical value of velocity or critical velocity. This is the minimum velocity with which the object should reach the highest point to be able to traverse the vertical circle. Okay, now let's consider the case where u is less than 5 gr, that is the velocity given at the lowest point is not sufficient enough for it to make the complete circle. What will happen under this condition? If u is less than 5 gr, then the object will lose its velocity at certain point. Let's say, let's draw it here. So this is the circular path, and it's given a velocity u which is less than the critical velocity required to reach the topmost point. So let's say at this point its velocity v becomes equal to 0. So if you consider, this is the center, let's call this height h1. So what we say is that, let's say at the point at height h1 the velocity becomes 0 before reaching the top, that is. So under such condition, equation number 1 will give us 0 equals to u square minus 2g h1, where h1 is the height, that means the velocity becomes 0. Therefore, h1 will be equal to u square by 2g. Also, let's say if the object loses the entire tension in the string, say at this point T becomes equal to 0, tension becomes equal to 0. Let's call this height to be h2. So equation for tension here will give us 0, T is 0 equals to m by r will be there, of course, m by r. Then we have u square plus gr minus 3g h1. Sorry, not h1, this is h2, right? So it will be h2. And so, solving we will get h2 equals to u square plus gr by 3g. Alright. Now these two are very important equations for us. We will note this down somewhere. Okay. Now we have found h1 and h2. h1 is when the velocity becomes 0 and h2 is when tension becomes 0 in the string along the path, when the given initial velocity is less than root 5 gr. Right? Now under such conditions, two cases might arise. One is that h1 is less than h2, that is the velocity becomes 0 before the tension becomes 0, the tension in the string becomes 0. And the next one is h1 is greater than h2, that is the tension becomes 0 before the velocity becomes 0 along the path. Okay, now let's consider this case. If the velocity has become 0 at this particular point, say while it's moving from here and it's here, the velocity is, there is no further, velocity has become 0. So the object will not move any further up. However, there is still tension in the string. So because of the tension, what will happen is that the string will still be taut. So Once the velocity becomes 0, due to gravity, the object will start accelerating downwards. So it will come back, retrace its path, and will move back and reach to the same height and go back and forth. So the object will be oscillating. So h1 less than h2 is the condition for oscillation of the object. The object will move up, go back, and keep oscillating in the circular path from this side to this side. Okay, to and fro motion will be there. Now, if we substitute the value of h1 and h2, the condition for oscillations will be u square by 2g must be less than or equal to, say, minimum of this equal to u square plus gr divided by 3g. Cross multiplication will give us, let's cancel the g's first. So 3u square must be less than equal to 2u square plus 2gr. That is to say, u square or u is less than equal to whole thing under root, square root of 2gr. So if the velocity given to the object is less than root 2gr, then the object will oscillate in the path. It will not be able to complete the circle. What happens if h1 is greater than h2? That is to say, if the tension has become 0 but there is still velocity becomes 0 at a later point of time in the trajectory. This means that when the tension becomes 0, the string will become slack. So it will no longer be able to hold the object in the position along the circle. So what will happen, the object will leave the circular path and will start moving as if it were a projectile. So it will leave the path if h1 is greater than this, h2. Okay, it will no longer move in a circular path, but it will move as if it were a free body, and it will move some other path. Now, for this, if we substitute the values, what we get is that u square by 2g must be greater than u square plus gr by 3g. That is to say, u must be, from the similar analysis, greater than the square root of 2gr. So if the velocity imparted is greater than square root of 2gr, however, it must be less than this minimum velocity 5gr. This must be less than this value, must be less than square root of 5gr. So in this range, square root of 5gr to square root of 2gr, if the velocity is there, in that case the object will no longer be oscillating, neither it will be able to complete the circle, but what will happen, it will go up to certain point and then leave the circle and move as if it were a free object, like it was a projectile at certain angle, right?